Welcome everyone to your next session at Coalesce. The call is coming from inside the warehouse, surviving schema changes with automation. I'm Julia Schotten and I'm part of the product team at dbt Labs, and I'll be your host for this session. In this talk, we're going to hear from senior analytics engineers at Aula Education, Louis Davies and Erica Pullum. They're going to share more about how they were in need of better automation to organize an increasingly complex customer data configuration. They turned to dbt packages to save the day, and in the next 30 minutes, they'll share more about how dbt-utils and dbt audit helper made their processes far more automated. Please join the conversation in the dbt Slack channel, Coalesce Schema Changes, and Erica and Louis will answer any questions you may have after their talk. I'm excited to hear some practical examples on how to use packages and macros. So without further ado, over to you, Louis.
Thank you very much. Yeah, so I'm Louis. I am here with Erica. Like the introduction said, we are senior analytics engineers. I'm currently at Aula Education. Erica also was. Currently, she's just switched to Hex though, a big move for her. What I wanted to do first is just explain a little bit about why we wanted to do this talk at all. The main problem that we had is that we have a series of separate but similar environments. I'll go into a bit more detail, obviously shorter in a little while, but the main thing that we have is that a lot of institutions, each needing their own environments due to a range of regulatory reasons and that kind of thing. There were some challenges that we encountered there when we were trying to set up our dbt pipeline that we thought were interesting to share, but also, even if that doesn't generalize to everybody watching this talk, an understanding of the dbt ecosystem that we build up is something that we think is really relevant to other people, like wherever you are in terms of your journey with dbt. First of all, I just wanted to give a bit of context about what Aula is, so that the rest of it makes a bit more sense. So Aula is a learning experience platform for higher education. Now, that means that we are a service where university students can go on and they get their content and they get their lectures and they get everything delivered to them. We are focused on high engagement practices. Now, the key thing that means for Aula is that we don't want to just be white labeled Google Drive for a university setting. What we want to do is really have interaction between educators and students. In the example here that you see on the right, that's interactive slides being presented with a quiz element. There's a chat on the side. And the key thing is that educators and students are in contact with each other, and there are open channels, and they are able to ask questions and engage with each other in that way. That's really important to us. So the next part is just framing the problem. I'll start with explaining how data works at Aula right now. The Aula app itself, like I said, we have these segregated customer environments. So each institution has their own virtual private cloud, and the database that powers the app is MongoDB. Each of those then are brought into our data warehouse, in this case, Snowflake. We then use Metabase for internal analytics, but that Metabase instance is also fed into the Aula app itself. So we provide not only analytics for everybody else in the company, but we also provide analytics directly to the product. So obviously that means that it's really important that not only are they correct, but they're highly available and they're reliable, and basically that we have high quality data. Now, in here, there's the first hint, the major hints as to what the problem we're presenting are, and it's this part. So there's the fact that we have these many customer environments. That is a problem in itself, just bringing those all together and making sure that we can centralize them in order to do analytics, but also the fact that we use MongoDB. Now, I know that not everybody will have used MongoDB, at least in my experience before Aula, I hadn't really used it, but I think that it's important to know the context about the differences between typical SQL. Now, this is a very quick primer, and my assumption is that most people watching this have some familiarity with SQL. So if you are dealing with a SQL database, your tables have a predefined structure. For example, if I have a users table, I know that it has a user ID and an email address and a username and all those kinds of things. I know that those columns exist. Meanwhile, MongoDB, because it's not a relational model, it's not SQL, the equivalent structure there is a collection. Now, the structure of that is not predefined, it's determined by the contents. But what does that mean? So in SQL, knowing that those columns exist, if I take that user's example, knowing, for example, that the email column exists, If it's not been populated for any reason, the user hasn't entered it, I just get a null value. That's fine. I still know the column is there. With MongoDB, if that has not been populated, it just doesn't appear in that record. If no records have had it populated, that column doesn't appear. So if for some reason that column doesn't appear in my data set yet, I have no way of knowing that there should be an email column there beyond an engineer telling me. So what this then converts to is that if we are bringing together this data from across multiple institutions, if we were working with SQL, I know that generally they're all going to have the same structure. They're all going to have the same columns. So if I go back to the Aula app, if I'm looking again at my users table, I know that they're all going to have those columns of user ID, email, whatever else. That's not necessarily the case with Mongo. If a column is not there, it'll be inconsistent. That is a problem. And when you bring both of those problems together, it creates some complications. So this is my sciencey bit now. So what we have is 42 environments. And each of those can have up to 40 collections. And that's the key thing, it's up to, they're not always all present. Each of those collections, depending on which one you're looking at, can have between 3 for our smallest and 39 fields for our largest model. Now, if anybody's quick with mental maths, you will be able to realize that this worst case scenario is, yeah, it's a big headache. So we had to change something. And the answer for us was dbt-utils, obviously on top of dbt itself, of course. Now, what we were doing before is we followed the best practices guide. And that best practice guide says that when you bring in your data sources and you define them in YAML, you then have them each source directly linked to a staging model. So we set everything up like that. This is an example. Again, I'll continue with the users collection example. So this would be how we would get every single users table to combine into just one single users table. Now, if you're having to deal with up to 40 different versions of this and then times 42 for the number of institutions that we have, you end up with a lot of models. It's not scalable, and you end up with a ton of boilerplate that is manually set up and very hard to manage. So this is the example. This is a summary of our first revelation, really. What we did is we used two dbt-utils macros, and they are union relations and get relations by pattern. These were the key for us. So the first one with union relations, that solved the problem of the inconsistency in the collections being present or whether the fields were present. That took that headache away. And the key thing there is, if, for example, email wasn't in my users table, union relations will look at the contents of all of my different tables and it will say, okay, that one doesn't exist in one particular source, I'll just fill it with a null. And when these things can change, not just at setup time, but they change over weeks as people ramp up and start using Aula more and more, and they use more features and more collections appear, that was a massive time saver for us. And then when we combine that with get relations by pattern, where you can use just standard SQL-like syntax or just strings to define what tables and what relations you want to union, it makes onboarding way simpler, like it says here. Those new collections appear automatically. It was a bit of a lifesaver. And what we end up with is that entire column of staging models removed. It doesn't follow that best practice pattern, but for us, it was way easier to manage it this way. Now, at first, when we did this, our sources were not nicely connected to our union model, as you see here, but we'll go into more detail on that later. So if I revisit my sciencey bit, my theorem of dbt complexity, what you end up with, if we put some more hard numbers to this, if you do this for all of these collections at once, is a 962 file pull request where you're on the order of just under 9,000 line changes. Now, some people would say that it's not reasonable, to make your teammates review this, but that's their view. But one thing that we did realize when we did this is this thing that we were patting ourselves on the back for, I'm really pleased with, it was just the start. What we needed to do was make sure that when we roll it out, we didn't break anything. We needed to keep the quality high, and we needed to make sure that we maintain trust. And this is where we had to look at how we audited these changes, because they were obviously very big changes. Now, we were already doing automated pull request tests, and that was enormously helpful for us. But what we then had to do is break that big change down into a series of smaller ones. We had to think of what are the most important collections that we rely on that really warrant a deep dive. Like, how do we make sure we roll it out without breaking anything and make sure that things are still consistent? And how do we make sure that if anything does change, we communicate it clearly to the rest of the business? One thing that we found after we'd broken it down and we started doing a series of smaller pull requests is that we wanted to simplify our feedback system, and this was really helpful, because rather than just leaving comments on pull requests and just saying, oh, have you considered this, or I'm not sure about this, we had a system where you have one of these 3 emojis that range from this is a showstopper and I think it's broken, to this is just something that I'm curious about and I want to check just for my own information. And that really helps make our communication clearer. But finally, one of the biggest helps was dbt audit helper. Now, this is another package, and this is an example of how you use it. This is more or less adapted from the docs to suit our example. What you essentially do is you get one table, which is your production version. You get a dev version of that same table where you've made these changes. And then what audit helper does, once you've said, for example, our last activity, depending on when we've done our last run, that might not match up. We know that might be different, but for example, we look at the primary key, we want to make sure that all the details are the same on that level. What Audit Helper does, and if you run this in the dbt Cloud IDE, it generates it all for you. So that's really helpful as well. So what it does is row by row, it tells you whether each column on whether the columns on both sides are present in the other. And from there, you can then explore. And there's actually, if you compile the code and you go and look at the compiled version, you'll see that there's actually a full breakdown available in there and different ways of looking at it, which is super handy. But this will save you a lot of time if you ever have to do something similar. So what this meant for us, what our new way gave us, these new collections added themselves as, like I said, as institutions ramped up and they started using different features and more of these tables were populated, we didn't have to check back over a period of weeks on repeatedly making pull requests and often making mistakes with those pull requests, because it's very hard to compare at that level. Obviously, the nice thing for us is that there's less manual effort involved. And like I said, there's way fewer errors. Our data is more complete. We're not missing as much stuff. We went from 900 models to below 200 because of the sheer number of boilerplate models that we got rid of. Obviously, that then had an impact on our runtimes as well, and they were reduced. I think on our first run, we probably shaved about 30 minutes off, which was very nice. But that was far from the end of it. And Erica is now going to talk about some of the other work that we did with our dbt project.
All right, thanks, Lewis, for that great start. So everything is great. We got rid of the work. We don't have to copy paste anymore. We're kicking back in our separate kitchens and making some popcorn. And that's when the calls start coming from inside the house. So this combination of get relations by pattern and union relations leaves you with a couple problems. If an institution starts using a new feature, the Mongo collection shows up, Stitch pulls it into the data warehouse, and now we have an untested collection that's flowing into our unions. So the problem of these untested sources is really a problem of timing. You don't want new data showing up in your warehouse faster than you can make and review PRs to get it covered. And with Mongo, remember that new tables can pop up anywhere, anytime. Chasing them all down would take way too much time and energy. So the way out is to automate everything. And when I say everything, the entire first layer of the dbt project. So snapshots, sources, the unions that Lewis is talking about that were really the foundation of our dbt project. So let's take a quick look at the tools that we're going to use to do that. To solve this problem, we need to auto-generate everything. And the tools we chose to do this are all within the core dbt ecosystem. Vanilla Jinja is more or less perfect for solving this problem. Its core is a templating language, and it happens to be easily understandable to people who are working with dbt. Once things start getting complicated, we're going to need some YAML to help keep things organized. More on that in a bit. And finally, we use Python to help read, render, and write. And instead of using dbt's Jinja engine, we're using out-of-the-box Jinja and Python's Jinja 2 package. So before we get going with the automation, let's look at Jinja, a primer. The dbt context can actually make Jinja a bit harder to learn. I had a hard time when I first started learning dbt Jinja because there's dbt specific Jinja as well as the more standard Jinja syntax. At its simplest, Jinja is a little bit like Mad Libs. So you have this template that has blanks and some rules like a noun goes here and a verb goes there, and you can fill in the blanks and render it back out to a full story. And that's that flow you're seeing on the left side of the slide there. When you're compiling Jinja templates in the Python context, you can actually pass an arbitrary dictionary into the template, and anything that matches up is going to be substituted. So we're going to do a quick syntax primer before we dive into the automation. So the top two examples here should be familiar to people that have done significant work with Jinja in dbt. The first example is an expression. Just like Mad Libs, we're going to fill in the blanks. Inside the double curlies, substitute one thing for another. Next up, we have statements help us add logic. So we can have ifs, we can have for loops. And then finally, if you're going to make Jinja templates that then create resource files like a SQL file or a source that contains Jinja, you have to be able to escape sequences. Escaping tells the rendering engine when to substitute as it renders and when to make a string a literal. This is really important because we need the output to be valid to dbt. There's two ways to do it, and both of them are on the slide here. There's the statement raw and end raw, which are really useful for long blocks. But if you want to do something like a ref, you want escaped and unescaped Jinja to coexist on the same line. And the second method of escaping expressions is more readable in that instance. What we're doing is building up a string that includes escaped curlies inside of the expression. There's this like outer wrapper here. And we're actually intentionally nesting our curlies. It's like a bit like crossing the streams. So I should note here that friends don't let friends write this kind of Jinja without a live parser. It's really hard to keep this syntax straight. So Randy's going to start dropping some examples into the Slack channel that you can use to test out some of the syntax concepts above. And now that we're grounded with some syntax, let's take a look at how this works for automation. So let's start with the sources because this is a little bit simpler and that was the top priority for us. Remember that we can have get relations by pattern pulling in the raw data before the sources before the sources themselves are tested. We're going to use substitution and statements to render a list of tables into this source schema file. And when things are pretty easy, like in this template, you can just have any logic you want in the template. So at Aula, for example, we had some tables that started with an underscore, and we had logic to add an identifier for the underscore users so that we could just name the source users and not have to hit the underscore key. But it might not make sense to put all your logic into the Jinja template. You're going to eventually overload it. So what if you have a lot of different source types or you have a lot of if-then logic going into the template? It gets overloaded pretty quickly. You might have an instinct to put some of the rules into the Python script that's running the whole show for you. But that gets complicated too, because then you have to hold like what's in the template versus what's in the Python script. So we thought the dbt ecosystem here and we turned to YAML. So we made this config file that helps keep everything organized. It's really nice because it's human readable. So we can have our template file and our file name and the output path where we want to put it. For each dbt resource that we're going to generate, so types of models, type of snapshot, type of unions, we're going to do a lap through the flow on the left. Get the template, substitute the data, and then output it to the correct location. And this config YAML file lets us define how all of that is going to work. We can also add special lists like the one in the source query section of that file, which lets us avoid hard coding logic into functions. That's really helpful for data inputs like we're expanding the list of tables on the previous slide. Now we've got all our ingredients. We've got a template, we've got a way to write rules that humans can read, and it's time to take a look at a high level at the Python script that ties all this. This is just a schematic diagram here, but to orchestrate all this, we have a Python script that is going to do laps through each resource defined in the configuration template. We're going to go to the information schema of the database so we know what sources exist, what has popped up, what calls have come from inside the house. And using the specifications in that configuration file, we're going to build a list of dictionaries. And each dictionary in the list is going to represent a dbt resource that we want to build. It's compatible with a template. So let's say I want to do 3 sources. I'm going to have a list of 3 dictionaries. Going back to our Mad Libs example for a Jinja, you can't put a noun in a blank intended for a verb and end up with a good sentence. So this first definition step helps make sure that there's a match between the templates and the data that we're going to substitute. We then loop over that list of dictionaries, which renders a template into valid source or model code and write each file where it needs to go. Now that we have our scaffold for how all this works, we're going to go to a scary code example. So this is a union template that covers all the different kinds of Jinja syntax we discussed, and it will put this back on your DAG. Lewis mentioned earlier that when you use get relations by pattern and union relations in common, your sources get disconnected. So we figured out a way to put them back. And this example is a little bit to take in. So Randy's also going to drop a version of this into the Slack that you can plug into the live parser to try out. So this template demonstrates all of the Jinja syntax that we covered a few slides ago. We have some expressions that are doing substitution. There's some statements that are controlling logic, and we have both forms of escaping Jinja to ensure that it ends up in the rendered file. Using get relations by pattern and union relations means the dbt parser can't properly resolve the dependencies of your union model. So the template shows how to use depends on to force them back onto the list. The new and improved way is the best of both worlds. We get all of the benefits that Lewis shared in the first part of the talk. We added a GitHub action to run this for us, which solves the timing problem of the untested sources become tested. And something that we really like about this solution is that it keeps to this core contract of dbt, which is that there's this one model that relates to an object in your data warehouse. Everything is still version controlled, everything is still traceable, and we can see what's going on with our sources. So, of course, this is all really cool. And you might be asking, should everyone automate? And the answer is probably not. You need to have the exact same kind of problem we had, where you have similar environments, so much going on that manual maintenance is not possible. If you or a loved one are using get relations by pattern and union relations a lot, you may be entitled to automation. I'm sure there's lots of other ways you could solve this problem, but one thing we really like about doing it this way is that the contract for dbt is this one file, one model, one table, and this lets everything stay traceable. Finally, of course, we have some lessons learned along the way. You want to make the dbt ecosystem work for you. So best practices are a great starting point, but you have to know the rules to know when to break them. Like Lewis said, the solution was only the start. Reviewing big changes takes time and effort. It's like a stress test for your team's working practices. You can probably guess in the chat which person submitted the giant PR and which person had to review it. Finally, extraordinary changes require extraordinary justification. There were real business reasons that we had to do this, and it supported what we were trying to deliver for Aula and Aula's customers. So with that, I'd like to thank everyone so much for coming to our talk today. Big thanks to Randy and the dbt Labs team for keeping everything organized, and we'll be in the Slack.